Again, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 4 to be on your screen. Let's get started, please. It's only a couple of problems, and then for number 3, it says to set up a Cornell note. Make sure it looks like the one on the picture as soon as you log in. I'll give you guys some time for that. And once again, reminder, cell phones. Make sure you put those away. Mr. Apodaca has been hammering this already since yesterday and today in the morning as well. We're going to continue working on that. So make sure you are moving along right away. Ready and... All right. Good, Sharon. And once again, reminder, this is being recorded. If you need access to the video, it's going to be on the YouTube channel in the afternoon, after lunch. So if you get calls, you're probably coming out on the video. Let's go! Carissa! Ascending order for number 1. What you get? Go. 2.1, 3.005, 3.01, 5.9, 6.007, 10.1. Hands, have you got that? That is correct. Let's go. I'm not going to ask you for the sum. By now you know what to do with that. Let's go to number 2. Ascending order. Pass someone, Carissa. Oh, Blair, what'd you get? Ascending order. Go. Very good. 2. Hands, have you got that? All right. Not bad, not bad. And we need a mean. Mean. Share with your neighbor again, and then Larry's going to pass someone. What do you get for the mean? Mean. And shorthand for that guy, start using this symbol. That's what we call mu. And we are going to be using that throughout the year. Larry, pass someone. Julissa. Oh, Julius. 6.7. 6 1/7. Ooh, 6.1. I'll just keep it short and do the wiggles here for approximate. Hands, you got 6.14? All right. Not bad, not bad. Let's go. We're on our way. Median. Mr. Q. All right. Is it in ascending order? Yes. There's 3 datas on this side, and right smack the middle is what? 7. Hands, have you got that? All right. Mode. Pass someone. Julius. Jacob, what'd you get for the mode? 7. Hands, have you got that? That is correct. And one new one that I'm introducing here is called the range. For those of you that remembered, basically you take the largest data and subtract the smallest data. Take the largest data and subtract the what? The smallest data. So what is the largest data here? 10 minus the smallest, which is 2. The range is 8. Range is 8. Cake, yes? Choco flan? Woo! Cut me a piece. Let's go. All right, once again, you should have gotten your Cornell note ready. I already sent you the screen. Send me your warm-up, see what you did. It's up on your screen. So, once again, you leave a column on the cell on the left for questions or cues that you need for your notes. On the right side, you need a Freyer model that looks like that poster over there. Make sure it's on your notes side right here, because we're going to need it. And there's the agenda. Copy the agenda, please. So once again, the agenda reads warm-up number 4. Did we finish that? Yes. Today we're covering best fit lines. Think about that one. Does it ring a bell for some of you? You're like, oh yeah, Mr. Q, I have a poster in my room. Right? And tonight's home plate, only one problem. Is that okay with you guys? One problem? Woo. Let's go. So, with that said, so let's see, we did the warm-up, we copied the agenda. The next thing was to check home plate, which I said to do what? To have a great day, right? However, write that code down on your paper, please, so you can have access to the home plate tonight on Nearpod. Code ADWNX. ADWNX. Since we still haven't gotten our books, I'm going to include the problem on the presentation. So like that, when you access Nearpod, just scribble over the screens that require you to submit something so you can get to the home plate. Does that make sense? All right. And once again, when you log in, make sure you log in with 1 and your full name or whatever period you're in. So, there it is. Once again, materials needed. We're getting our scientific calculators pretty soon. They said that they're on their way, so hopefully we'll get them within the next days. So we'll get that done. You need your notebook. If you can get it, graph rules, because we're going to be graphing as well. Pencils, highlighters, 4 color pens, or at least 4 different colors so that you can follow along as we move along the lesson. And we will get our textbooks next week. Okay? All right. So, with that said, look at your home plate. Let's go. Let's go. Woo. All right. So, at the bottom left of your notes, write it down. I can model linear relationships, also known as best fit lines. I can model linear relationships, also known as best fit lines. And as you're writing that down, I would ask the question, what is the concept or the main idea for today? Look up, look at it. What would be the main idea? Tell your neighbor, main idea for today. Main idea. Yeah, linear relationships are best fit lines, yes. And what are we going to do today? We're going to model. No, we're not going to, walk the runway. It's model meaning graphing and such. So, we good so far? Yes? All right, all right. I'll leave that up for a little bit. Make sure you get your Cornell note ready. You do need a Freyer model in there. You sometimes say. So once again, you wrote in the center, linear relationships are best fit lines in your Freyer model. Definition, a straight line that best fits and provides a good description of a set of data. To get started with our school year, the data is going to be plotted on a graph. So each point, let me repeat that again, each point that you see is considered data. Each point that you see on the graph is considered what? Data. Each point is considered data. Yes? All right. So what does it look like, Mr. Q? Here it goes. Look up. Copy that as best you can. And notice that I made the line in green because the main idea is in what? In green. Best fit line. That's my line. That is what best fits that data, which is all those points. So, once again, what are we looking at today? Linear relationships, also known as what? Best fit lines. What was the definition? Well, it's a straight line, Mr. Q. That what? That best fits and provides a good description of the set of data. When I say data, according to this graph, tell your neighbor what I'm talking about. What am I talking about when I say data? What am I talking about? All the what? All the points on the graph. That's data. All right. Questions, comments, autographs. We good? So, this is a best fit line. Now, let me show you what is not. Look up to the other side. Now, I hope you can see it. However, talk it over to your neighbor. Let them know why that one is not a best fit line. Tell your neighbor, why is that one not a best fit line? Like Jacob's got it. Very good, Jacob. Julius got it. Very good, Julius. I see you. Cassandra's got it. All right, Cassandra. So, who went last, by the way, on the warm-up? Who? Jacob? Pass someone, Jacob? So they can help us. Why is that one not a best fit line? Who? Jay, why is this one not a best fit line? Not a straight line. Obvious? Yes? So question. Let me ask you a question. Critical attributes is basically what makes this what it is. What would you tell someone what a best fit line is? What would you tell someone? And I'm going to write it as a hashtag. Hashtag what? If you were to send a text to someone with that picture, you would say what? Hashtag what? Everyone? Straight line. Hello. Straight line. That is correct. And the second hashtag that I'm going to add, best fit the data. Pretty obvious, yes? Straightforward? Yes, I think you. All right, good. All right, I'm going to send you a screen. Let me see your notes. I want to see that you filled out your FAIR model. Send me that, please. So do me a favor, for this next part, writing utensils down, hands off the keyboards, eyes up here, here it goes. It's going to go pretty fast, so stay focused. We're going to be talking about determining association of data. What do you mean by that, Mr. Q? We're going to be graphing stuff, and all the points that we graph, they have a certain association. And here they go. There's three types of association. Don't copy that, you're just paying attention. Focus, please. Either they have no association, they have a positive association, or they have a negative association. Okay? So let me show you what no association looks like. I start plotting points according to the data that I get. That has no association, which means you don't really see a pattern to it. Now let me clarify by doing the next one. Look up to the screen. A positive association, somehow, when you start plotting points, start looking like that. Talk it over to your neighbor. Let them know what's the difference between no association to positive association really quick. Tell them what's the difference one to the other. All right, so here we go. No association, just to clarify, you don't really have a pattern as to what's going on here. However, positive association, look up. Notice it starts down here and it starts going in what direction? Up. It starts going upward. Everybody see that? Therefore, let me send you a screen. And I want you to show me a negative association on your screen. Negative association. I showed you no association. I showed you a positive association. You're showing me a negative association. All right. And since I'm recording this, let me show you what my beautiful students sent me. Those of you that are following on YouTube. Negative, 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 negative. Actually, 23 is a positive. Oh my goodness. Negative, 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 negative. Do we get the point? Or should I say, do we get the points? That was quick, right? Anyways, go ahead and copy that. Please copy no association, positive association, and negative association in your notes, please. All right, good. So, here we go. Next, for tonight's home plate, you're going to be given data in a table. So these are the things that you're going to do. Number one, you're going to plot the data on a graph. Then draw a best fit line. From there, you're going to write an equation for the line. We're going to do one example together here right now, so you guys can remember what to do with that. Like I said, this is more like a review of some of the data and probabilities that you covered before, but I'm just trying to revisit some of these parts and revisit some of the formulas that you need. Okay, here we go. So underneath that, write example Q and copy this data, this table, X and Y. For X, we have 2, 3, 5, 1, 4, 3, 9. And for Y, we have 1, 6, 2, 4, 3, 7, 9. And the instructions are graph the data and identify a best fit line. So here we go. So we need to graph this, and if you notice, look up to the screen, all the X values are what? Positive values. How about the Y's? Are all positive. Therefore, I want you to do this. Only one quadrant, like so. This is X. This is Y. And we're going to start at 0 right here. Then we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bless you. Same thing for the Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's plot our points. Here we go. 2, 1. 2 of X, 1 of Y is about right there. 3, 6. 3, 6. Now, mind you, your scaling might be a little bit off than mine because of how we did the scaling of the tallies, okay? 5, 2. 5, 2. 1, 4. 1, 4. 4, 3, 4, 1, 2, 3. 3, 7, 3, 7. And 9, 9. 9 and 9. All right, let me pause the tunes in the back just to make sure we got this. All right, show your neighbor your graph, see if they're in the right direction, please. All right, thank you. So, with that said, they want us to sketch a best fit line. First, we need to look at the data and see if it has no association, positive association, or a negative association. Look at the data. What kind of association do you think it has? Share with your neighbor. What kind of association do you think it has? Kind of looks like a positive one, right? It first starts slow, but then all of a sudden we have that one way up there, so it's taking us upward in that direction. You're like, Mr. Q, well, I see that it goes like this and then down. Yeah, but this one, the last point makes the data start going in that direction. So this is what I'm going to do. I'm going to draw a line, writing utensils down, look up, and it has to, check this out, it has to split the data evenly. And it has to split the data where you have the same amount of points at the bottom than at the top. Okay? So watch. Here it goes. Look up to the screen or you're going to miss it. And once again, get off those phones. Ready? Here we go. Let's see. I have this point over here that I can reach, and I need to start somewhere over here. Let's see. I'm going to start at 0. Is that a positive association? Yes. How many points do I have above that line? 1, 2, 3. How many below? 1, 2, 3. Everybody see that? All right, copy that, please. So here goes the steps. You are given a table of data, you graph it, and then you draw your best fit line. Okay? So far, so good. And the next thing, we just need to write an equation for that data. For that equation, we need actually 2 equations. So look up. Let me take you back in time. Those of you that were with me, you're like, oh, I remember this. Yes. Y equals mx plus b. Remember that one? Yes. And the second one that we need is this one. M equals y sub 2 minus y sub 1, x sub 2 minus x sub 1. So to write our equation, look up, please. First, we need a slope, which means the how many steps we take up and then to the run from point to point on the line. And then we need to substitute those values in here to get that slope. And the B stands for the y-intercept. Where does that line start? So let's start with that one. That one's the easiest. So go to your graph. Where did that line start? Everyone? 0. So we put plus 0. So now all we have to figure out is what? The slope. So there's 2 ways. We can either use the formula, or you can actually count steps. Here we go. Look up. To get from here to here, how many steps up? How many? 9. And how many to the right? 9. So that means my slope is 9 over 9. Therefore, my new equation is y equals 1x plus 0, or y equals 1x. Straightforward, yes? Now, if you wanted to use the formula, check this out. You take this point is 0, 0. I'm going to label that x sub 1, y sub 1. This point right here is what? X sub 2, y sub 2. So let's see, this one is 0, 0. This one is what? 9, 9. You substitute that in here, and that's how you get your slope. All right? Is it coming back little by little? Yes? All right. So from 1 to 5, how comfortable are you with this kind of problem? 5, 4, okay. 3s, okay. We're getting there little by little. So, send me your notes. I want to see that, make sure that you're taking copious notes. As you're sending me that, turn the paper over, or if you have space there, label it example super Q. And it reads, graph the data and identify the best fit line for shoe size in Mr. Q's statistics class. They're going to write example super Q. I'm going to make a table, X, Y. The X is shoe size. and the Y is the number of people for that shoe size. So I'm going to start with, how about 4.5 or 4.5 size? Let's go to 5, 5.5 or 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10. I'm going to go a little bit over because, like, if you ask me, I'm 13, 14, depending what kind of shoe I'm wearing. You're like, oh, snap, Mr. Q. Oh, yeah. Play some kickball. Go. 10.5, 11, 11.5, 12, 12.5, and I'll stop at 13. Woo-wee. Which means once you gather data, and this is how we're going to gather data, watch. We're going to do an exercise here in class, and for those of you that are following on YouTube, I'm going to stop the video right here. Once again, you got the code at the beginning where you can go to Nearpod and get the home plate or the practice for tonight. All right, I'm logging off. Peace.